Hello everybody, and in this recording we're going to see how to go about factorizing cubic polynomials. And after having successfully completed all of this, we will also see how the same logic that we use for factorizing cubic polynomials can be used for polynomials of higher and higher degrees. Okay, so what constitutes, first and foremost, we need to go back to the first principle and understand what is a cubic polynomial. A cubic polynomial is any polynomial with the highest degree in that function to be of the power 3. And so what I mean by this is that if I were to make a general equation for f of x, and if I were to make a cubic polynomial, then it will have the highest degree to be 3, which is seen over here with this ax cubed. And so in this lesson, in this video, we're going to see one method in which we can factorize such cubic polynomials. Okay, so given we have a cubic polynomial that's defined by x cubed plus 3x squared minus 25x minus 75, how do we go about factorizing this? So to basically factorize this, we need to first see how what was the process and operations underlying when we factorized functions when we were in the quadratic realm. So if we had, say, an ax squared plus bx plus c, which is a quadratic function, then when we were to factorize this, we'll be factorizing it into two linear factors. So say x plus, I'm just saying some random factor, and this thing, right? So here these factors were linear because the highest power to the factors was 1, right? Similarly, we can factorize our f of x into two such brackets where one is a linear factor. We can factorize it further, by the way, a linear factor and a quadratic factor, and this quadratic factor can be further factorized into more linear factors. But for the purposes of this explanation and this video, we will see how we can factorize this into a linear and a quadratic factor. Okay, so our objective is to now find this linear factor. So how do I go about finding this? Basically, given that we have a linear and quadratic factor for this cubic polynomial, the rightmost element, which is not a product with the variable x, will multiply to give this final value minus 75. And so for that, we need to determine what are the different factors for minus 75. And that includes 1 and minus 75, minus 1 and 75, minus 3 and 25, 3 and minus 25, and 5 and minus 15, and minus 5 and 15. So essentially, what am I going to do with all of this? So when we found the factors in the quadratic realm, we saw that essentially these factors are those values for which, so if d was the factor, we will get x is equal to minus d as the value, which is a root of the function h of x, which means that for some function, say h of x, sorry, that's not a quadratic function. So a quadratic function can be either can look like this or can look like this. And so the roots of the function h of x are those values of x for which the function intersects the x-axis. And so these roots essentially represent the x-intercepts. So now what are we trying to do with this these value factors of minus 75? Basically, one of these values will be the linear factor for f of x, which means that one of these values will be that root for which f of x will intersect the x-axis. So what do we do with this kind of information? If it intersects the f of x, if it makes the f of x intersect the x-axis, that means f of x should be 0. That means x and an x-intercept is that point for which y is equal to 0. Y, or whatever, if our function is an f of x, then f of x is equal to 0. So we're trying to find that value. So what we do in order to do that is we substitute x for all of these values and see what is that value that gives us f of x to be equal to 0. So let's try f of 1. When we try f of 1, we get 1 cubed plus 3 minus 25 minus 75, which is 4 minus 100, which is equal to minus 96. So clearly this is not equal to 0. So now we go on to the next factor, which is f of minus 1. We will get minus 1 plus 3 plus 25 minus 75, which is 2. 1 second. So we were putting minus 1, right? So this becomes 25. Yeah, and this is minus 75. Yeah. So this is 2 minus 50, which is equal to minus 48, which is again not equal to 0. We go to the next factor, f of minus 3, which is minus 27 plus 3 into minus 3 cubed will be 9. So let's put 9 here. Minus 25 into minus 3 minus 75, which is equal to minus 27 plus 27 plus 75 minus 75. So we can see that all these cancels out, and therefore we have found one root of the function f of x, which is x is equal to minus 3, which implies our linear factor will be x plus 3. Now how do we go about using this? Now we can deconstruct our original equation to be f of x is equal to x plus 3 into ax squared plus bx plus c, because I had said earlier that we would get a linear factor followed by a quadratic factor. So now what we need to do is equate this to our original equation, which was x cubed plus 3x squared minus 25x minus 75. And upon multiplying this and equating the coefficients, we should then get the values of a, b, and c. So let's do this. So we'll get, upon multiplying, this will be ax cubed plus bx squared plus cx plus 3ax squared plus 3bx plus 3c is equal to x cubed plus 3x squared minus 25x minus 75. Right? So let's simplify this equation further. This will be ax cubed plus b plus 3a x squared plus c plus 3bx plus 3c is equal to all of this. Right? Now we equate the values, the coefficients. So the coefficient of x cubed, a, is equal to 1. So we get that. So a is equal to 1. Now we have b plus 3a, which is the coefficient of x squared, to be equal to 3. So this will be equal to 3. So since we already know that a is 1, we can just put it as b plus 3 is equal to 3, which implies that b is equal to 0. And finally, we can find the value of c by just equating this c plus 3b is equal to minus 25, because c plus 3b is a coefficient of x, and likewise we have coefficient of x on the right hand side to be minus 25. And since we know that b is equal to 0, this implies that c is equal to minus 25. Right? So upon substituting this back into our linear factors, we will get f of x is equal to x plus 3 into x squared minus 25. And we know that we can factorize this further as x plus 3 into x plus 5 into x minus 5. And there you have it. We have the factors of the original cubic polynomial, and the factors are those values at which we will get the function to intersect the x-intercept, and those values are x is equal to -3, x is equal to -5, and x is equal to 5. And these are our the roots of our polynomial. I hope you liked it. Keep watching more of my videos to get such tips on how to go about solving such cubic polynomials and other polynomials and other mathematical related stuff.